Hi Geometry. This is Unit 6, Lesson 13, Finding Intersection Points. The additional notes. So we looked at finding intersection points by using the graphs, and then to verify the intersection points are on the graph of, for example, the circle and the line, or the parabola and the line. And in this activity, we're going to look at finding the intersection points algebraically. So to begin with, one of the methods we can use is substitution. And when I do this, what I want to do is isolate either the x or the y, and I want to substitute it into the other equation. This allows me to have an equation with only one variable, and I can solve for it and find its value. So, for example, in this first problem, the first equation is linear. I know that because it's an x to the first and y to the first. And the second equation is quadratic. And I know that because my y is to the first power, and I have an x squared in the problem. So I'm going to solve the first equation for y by simply subtracting 4x from both sides. When I do that, I get y equals negative 4x minus 20. Now I can take this value and substitute it into y in the second equation. When I do that, I get negative 4x minus 20 equals x squared plus 5x minus 2. And if you remember from when we were solving quadratics earlier this year, when I want to solve a quadratic equation, I need to get it set equal to 0. So I'm going to move everything so my x squared term is positive. So that means I'm going to add 4x to move it over to the other side. I'm going to add 20 to move it over to the other side. When I do that, on my left side I have just a 0. Perfect, that's what I wanted. On the right side I have positive x squared, which is perfect, that's what I want, plus 9x plus 18. So I'm going to factor this, and if you remember, we write our AC at the top, where our A in this problem is 1. So I have 18 at the top and 9 at the bottom. This is the number I want my side numbers to add to, and this is the number I want them to multiply to. So it looks like I want 3 and 6. So since my A is 1, I can just write the 3 and write the 6 in my parentheses. So now I set, one of these two must be 0 by the zero product property. So I set my x plus 3 equal to 0, and I set my x plus 6 equal to 0, and I get that x equals negative 3, or that x equals negative 6. So those are my two values for x when these two graphs intersect. So now I need to find the two values of y where that happens. So when x is negative 3, I could find my y value by plugging it into either one of my two equations. I'm going to plug it into my linear equation. So I have 4 times negative 3 plus y equals negative 20. So negative 12 plus y equals negative 20. I'm going to add 12 to both sides, and I get my y equals negative 8. So it looks like negative 3, negative 8 is one of my intersection points between this line and this parabola. Let's do when x is negative 6. Let's find my y value. Again, you could plug it into either equation. I'm going to use the linear equation, and I get negative 24 plus y equals negative 20. I'm going to add 24 over, get y equals 4. So negative 6 comma 4 looks like it is the other intersection point. In the classroom, we talked about how to type these two equations into Desmos and locate where they intersect. So at this time, I'd like you to try that so that you can see the way the graph looks, and you can see at negative 3, negative 8, and negative 6, 4, it does indeed intersect. So why don't you pause this video and try solving number 1. Number 1 is pretty much the same problem, and come back to this video and let's see how you did. So let's see how you did. Did you get 5, 8 and negative 1, 2? So in green, you can see where I set my two equations equal to each other, And then I moved my x over and my 3 over because I moved them to the right, primarily because that's where my x squared was, and my x squared is positive. I want to go to the side of the equation that will have my x squared positive. It makes my factoring so much nicer. So then when I factor, I found that my two side numbers were -5 and +1. And so then I substituted them in. Now I have my factors. I've got to set each factor equal to 0, and I would get x equals 5 or x equals -1 when I do that. So in blue, you can see where I substituted the 5, and I could put it in either equation. I chose the linear equation because the math seems so simple to add 3. And I would get 8 when x is 5, and then when x is -1 and I substitute that in, I get 2. So now let's look for 2. 2 is a little different. This is a circle equation where my center is 0, 0, and my radius is the square root of 18. And this is a linear equation. Now, if you look at the answer key, you'll see that I resolved the linear equation to have a y equals. It's just a habit. I really get used to solving for y and substituting that value in. But as it's written here, it'd be real easy to substitute in 6 plus y for my x. So I'm going to substitute that in and then do my math, and it's going to allow me to solve for y. So in the video, I'm going to be solving for y first. So let's do this. I have 6 plus y gets put in for x, and that's squared, plus y squared equals 18. So when I have a binomial squared, remember that's 6 plus y times 6 plus y. Make sure you do your box or FOIL correctly, and you'd get 36 plus 12y plus y squared plus the y squared that was already there, this guy right here, equals 18. So I have 2y squared. When I add them, 1y squared plus 2y squared is 2y squared. I'm going to write that first because it's my highest exponent. And then plus my 12y, and I'm going to write my 36 last because that's my integer. I'm not ready to factor yet though because it's equal to 18. So now I'm going to subtract my 18 over from both sides, and my final equation here is 2y squared plus 12y plus 18 equals 0. But before you factor, this is not really a problem with an a that's 2. If you look at all the terms, they all have a GCF of 2. Now, I want to not factor that out. I'm not factoring this. I'm solving it for for y. And so I'm really going to divide both sides. I'm just going to get rid of that factor of 2. I'm going to divide both sides of my equation by a 2. Every single term. So I'm not really factoring it out in front because I'm not trying to factor this. I'm trying to solve it. I want to get y equals a number. So I'm going to divide everything by 2 and get y squared plus 6y plus 9 equals 0. I've got my 9 on top. I've got my 6 on the bottom. I multiply to my 9. I add to my 6. So it looks like it's 3 and 3. So y plus 3 times y plus 3 equals 0. When I set each of those equal to 0, I get actually the same value. I get y equals -3. This is really telling me that there's only one x coordinate where this circle and this line intersect. So let's see what happens when we substitute, one y coordinate. Let's see what happens when we substitute in our -3 for y. Again, I'm going to use the linear equation for my substitution. So I have 6 plus -3, or 6 minus 3 equals x, or x is 3. So I get just one answer here. My answer for my intersection point is 3, -3. This means if you graphed these two equations on Desmos, you would see that this line does not go through the circle. This line intersects the circle at only one spot, and that one spot would be 3, -3. So now let's talk about elimination. Elimination is very useful. I didn't really use it. In fact, I don't think I used elimination anywhere in the 8 problems on the back of this worksheet. But you are going to find at the bottom of this worksheet, number 4, that elimination is a super useful method. So let's remember elimination. Elimination means that I am going to try to add my two equations together, and I would like to get one of my variables to cancel. So looking at this, if I'd like to get my y to cancel, for instance, it'd be nice if one of them was a negative y. So I'm going to multiply this entire equation here by -1, every single term. So I'm getting, when I do that, I get negative y equals negative x squared minus 5x plus 4. I haven't changed the value of my equation because I multiplied both sides by -1. Now you'll see when I write my top equation above it, y equals x squared plus 3x plus 2, that when I add these two together, conveniently my y terms cancel. I'm going to be left with just x's, which is awesome. I can solve for x. Even better, my x squared terms cancel. So this cancels to 0 on the left. My x squared terms cancel. And it looks like I get negative 2x plus 6. So in order to solve for x, I either need to add the 2x over or subtract the 6 over. It doesn't really matter which way you go, but I get negative 6 equals negative 2x, divide by -2, and it looks like my x is positive 3. So to find my y value, I'm going to plug that in for x. So for example, using my top equation, y equals 3 squared plus 3 times 3 plus 2. So it's 9 plus 9 plus 2, or it looks like my y is 20. So my intersection point would be positive 3 and 20 for these two. And notice they're both a parabola. These are two parabolas. So when you type in these equations into Desmos, you should see that your graph is two parabolas. I think one's like a little one and one's a bigger one, and they intersect over here at one point, which is 320. So now try substitution. Actually, my favorite method. You'll notice that both of them are y equals. So I really can set y equal to y, or x squared plus 3x plus 2 equals x squared plus 5x minus 4. Your x squareds are going to cancel. Again, you could work that all out. You're going to get x equals 3 again. You're going to plug it in and get 20 again. This problem could have been done either way. So I'm going to have you, let me move my paper down. So then on number 3, this one could be done by substitution just as easily as it could be done with elimination. In fact, I'm going to use substitution because here's my thinking. If I used elimination, I could multiply this entire bottom one by -4. That'd be a great way to do this problem. Or you could set for x squared minus 29 equal to x squared minus 17. That's my substitution. You can use any method you want. My personal preference when I can do it is substitution. So let me write my 4x squared minus 29 equal to my x squared minus 17. And I'm going to subtract, basically you have two ways to solve this, and I probably should talk about both of them in this video. Since there's no x term, there's only an x squared term, I'm going to isolate x squared. So I'm going to subtract x squared from both sides. When I do that, I get 3x squared minus 29 equals negative 17. I'm going to add 29 to both sides. I get 3x squared equals 12. You have to put the 29 on top and subtract the 17. And so now that I've isolated my x squared, I'm going to divide by 3. I get x squared equals 4. I'm going to take the square root of both sides, and I get x equals plus or minus 2. Remember, when we're doing a quadratic equation, we take the square root. We have to account for both roots, the positive and the negative. So this is really two answers for x. So I'm going to have to substitute both in to find my value for y. When you do that, you're going to find that you get 13. So this would tell me that 2, 13, and also when I substitute in a -2, I also get, I'm sorry, it's a -13 that you get. You also get -13. Those are the two places that these two parabolas intersect. Now I want to talk about a second way to solve this one. So some of you might have thought, well, it's quadratic. I'm going to get it all equal to 0 and factor. You can do that in this problem. So let's say I pull everything over to the left side. I'm going to subtract x squared over, get 3x squared over. I'm going to add 17 over and get minus 12. And then that would be 0. So now I'm going to factor out my GCF of 3. Don't forget your GCFs when you're factoring. And I get x, and I could also divide both sides by 3. Since I'm solving, it doesn't really matter. Get x squared minus 4 equals 0. If you remember, x squared minus 4 is the difference of two squares. This is my nice friendly dots. And I could write this as x minus 2 and x plus 2 equaling to 0. This is my fully factored form. And if I want to solve it, it doesn't make any sense to set 3 equal to 0. Since there's no x with it, I don't even worry about it. But I am going to set my x minus 2 equal to 0, my x plus 2 equal to 0. I get x equals 2 and x equals negative 2. Again, and when I plug them in, you'll find that you get your negative 13. You would get the same answer as you got solving it the other way. So now let's look at number 4. Number 4, I believe the equation on the top, this is an ellipse. You really should graph this one on Desmos. I want you to see the ellipse. The ellipse is sort of an oval in shape. So I think you have, the ellipse on the screen. And then this is going to be a hyperbola. And you'll see that it looks something like this. And although you don't need to be able to do anything with these curves this year, or really even know about them, I wanted to just show you what they look like. And you'll notice there's 4 intersection points. So when we solve this, we're going to get 4 answers. Now you'll notice that none of the problems on the back side of this worksheet have 4 answers. None of them are an ellipse and a parabola or hyperbola. All the problems on the back of this are like a circle and a line, a parabola and a line. Maybe there's a parabola and a parabola. So they're much more basic. But let's take a look at this. This is a perfect example of when elimination really is the best way to do this problem. You can eliminate either the x squared term or the y term. It doesn't matter. We're going to get the same correct answers either way. I think I'm going to multiply the top equation by negative 2, and then my x's will cancel. So when I do that, I'm going to just write my top equation underneath my bottom equation. So I'm going to get a negative 2x squared. Negative 2 times 2 gives me a negative 4y squared. And negative 2 times 17 gives me a negative 34. So now I'm going to add these together. Well, my x's cancel like I wanted, and I get negative 7y squared equals, I have to visualize the 34 on top of the 6. 34 minus 6 is 28, but since 34 was bigger, then it's negative 28. So now I have y squared equals, let's divide both sides by negative 7. I get y squared equals 4. So y equals plus or minus 2. Those are my 2y values. So let's plug them in and see what I get for my x values. So for when y equals 2, I could plug it into either equation. They're both equations that I could use to find my x term. So let's do my x squared plus 2 times my y, so I'm using the top equation. My y squared, which is 2 squared, equals 17. So then 2 times 2 squared, that's 2 times 4, that's 8. So x squared plus 8 equals 17. X squared equals 9. Let's take the square root of both sides, and I get x equals plus or minus 3. So that gives me 2 coordinates. That gives me positive 3 for my x and 2 for my y. It also gives me negative 3 for my x, along with that 2 for my y. So let's look at y equals negative 2. When I plug in a negative 2, you'll see the math is pretty much identical. You get x squared plus 2 times negative 2 squared this time equals 17. Negative 2 squared is still a positive 4, times 2 is a positive 8, and I'm going to subtract my 8. Again, I get a 9. Again, I take the square root, and I get plus or minus 3. So that tells me that when x is 3, negative 2 is also a solution, and when x is negative 3, negative 2 is also a solution. You'll see when you graph these, this is my -3, +2. This is going to be your -3, -2 intersection point. This is going to be my 3, 2, and this will be your 3, -2 intersection points on your graph when you look at Desmos. So I have 4 answers for this problem where those two shapes intersect. So at this time, the lesson is over. You can work on any of the problems on the back side that you would like. I think I'm going to go through and just do a couple of these. One I want to talk about is 2, because 2 involves, if you look at the top equation, it has a -x². There's nothing wrong with that. You can do the problem with that. However, it is better to work with a positive x² term. So let's say I was doing this one, and let's say I wanted to use substitution. So I set my line, which is x plus 6, equal to my circle, or my parabola, sorry, which is -x² minus 3x plus 2. If I'm solving this, I'm actually going to add the x² over, and so I'm going to add the x² over, I'm going to add the 3x over, and I'm going to subtract the 2. I'm actually going to move everything to the left side, adding an x² over here, adding a 3x, subtracting a 2. So I get x² plus 4x plus 4 equals 0. This entire right side cancels out. And I do that because I really want a positive x² term in order to factor easily. And you would do your diamond. I would have a 4 on top for it to multiply 2. I have a 4 on the bottom for it to add 2. It's 2 and 2. I'm going to stop there. I think you can probably finish it the rest of the way. Let me jump over to number 3. Number 3, in order to use substitution, for instance, I have to have it x equals or y equals. It doesn't really matter which one you do. I tend to like to solve for y, so I would subtract x from both sides, and I get y equals 5 minus x. And now I'm ready to substitute that in for y in my top equation. So I have 5 minus x equals 3x² plus 2x minus 1. This is a line and a parabola. So I'm going to, because it's quadratic, I'm going to get everything on one side equal to 0. So I'm going to add x over, I'm going to subtract 5 over, and I get 0 equals 3x² plus 3x minus 6. Now, before you start factoring, this isn't really a problem where your a is 3. In this problem, there's a GCF here. My GCF is 3. So I actually want to divide the entire equation on both sides by 3. And 0 divided by 3 is 0. And then divide by 3, I get x² plus x minus 2. This is really quick to factor. I have a -2 on top, a 1 on the bottom. I think to myself what adds to 1 while multiplying to -2. I think that's going to be a +2 and a -1. So I get 0 equals x plus 2 times x minus 1. When I set x plus 2 equal to 0, -2. And when I set x minus 1 equal to 0, I get x equals 1. Let's substitute those back in. I'm going to use the second equation. So -2 plus y equals 5, or y equals 7. So it looks like I have -2, 7 as one of my intersection points. Let's do the 1 plus y equals 5, y equals 4. So one of my intersection points would be 1, 4. And so that looks to be where my line and my parabola will intersect. Thank you so much for watching, and if you're having trouble, come to office hours or bring your questions to class. Thank you.